We can now describe how a covalent bond forms, but we must understand that there are different types of covalent bonds, and a bond formed between two identical atoms will necessarily be different from one formed between two different types of atoms. A covalent bond that forms between two identical atoms, like the bond contained in a molecule of H2 or any other diatomic molecule consisting of one element, then the electrons will be shared precisely evenly. The two atoms have precisely the same characteristics, so there is no basis for one atom to hold on to more of the electron density than the other. We would also call this a nonpolar covalent bond. If the two atoms participating in the covalent bond belong to different elements, like a molecule of HCl, it might be possible that the electrons are not shared evenly, but rather that the electron density is more attracted to one of the atoms than the other, which we can see is happening because the cloud of electron density is more prominent on the chlorine atom than the hydrogen atom. If the electrons are shared unevenly, this is called a polar covalent bond. In a polar covalent bond, the atom that is electron deficient is symbolized with a delta plus, and we will call it partially positive. The atom with the electron excess will be marked with a delta minus, and we will call it partially negative. These partial charges are not formal charges, they just represent the unequal distribution of the electron density in the bond. We can also mark this with a dipole arrow. Here the arrow will point in the direction of the electron excess, with an additional line on the other end to resemble a plus charge, indicating the side with electron deficiency. Many molecules, like water, will have polar covalent bonds, and it is these differences in polarity that make chemistry possible. So we will want to understand them and the reason why the electrons in a covalent bond might be attracted to one atom more than another, which is what we will learn next.